For the study guide for sections 5.1 through 5.3, we're going to go ahead and work through every single problem. Starting with number 1, which is right up here. Number 1 asks us to simplify the three ratios, and can someone tell me how would we go about that? Well, what I would do is I would break down each part of the ratio into their simplest multiplicatives and see if I can cancel out anything from the top and anything from the bottom. So the 8, I can break that up into 2 times 4. I can break it up further, but I'm not going to need to. And the 18, I can break that up into 2 times 9. What can I do next? I can cancel out the 2's from top and bottom, which leaves me with the simplest form right here, 4 over 9. And that's essentially my answer, because I can't simplify that any further. 9 and 21. What can I cancel out of both of those? Well, I can cancel out a 3 because I can write 9 as 3 times 3. The 21 I can write down as 3 times 7. So if I take out a 3 from both top and bottom, I'm left with just 3 over 7. I can't simplify that down any further, and that happens to be my answer in this case. The 10 and the 35, what can I cancel out from both of those? Well, a 5, because a 10 is 2 times 5, and a 35 can be written as 7 times 5. So 5 from top and bottom goes, which of course leaves us with 2 over 7 as our simplest form ratio. 2 over 7 and 10 over 35, it's the same ratio. 3 over 7 and 9 to 21, same ratio. 8 to 18 and 4 over 9, same ratios. They're equivalent ratios. These are just the simplest forms. Questions? Number 2 asks us to find 4 equivalent ratios, 2 larger and 2 smaller than the initial ratio that I gave you. How can you do that? And there's multiple ways of doing this. What is one way that you can go about? Well, as I said, there are a lot of things that you could do, but one of the easiest things to do is to multiply the right side by 2, so double again, and the left side, reduce it by 2. Half it and half it again. So on the right side, I'm going to multiply by 2, both top and bottom, of course, which is going to give me 12 over 28. And then I want to multiply by 2 again, or double, which gives me now 24. And on the bottom, if my math is correct, that's 56. So those are the 2 that were larger. Over here, I'm going to half it. I'm going to divide by 2. So that gets me 3 over 7. Next, I'm going to half it again. And this one, I think a few of you were a little bit confused on, because it would result in decimals. That's okay. We've learned that decimals are fine as far as math is concerned. They don't scare me, they shouldn't scare you. Half of a 3 is 1.5. Half of a 7 is 3.5. So now I have 4 equivalent ratios to my original, or 5 total, but 4 that are equivalent to my original ratio. All of these are equivalent to my original ratio. What did I do? And I'm not going to write this out, but I doubled each time on the right side. I reduced or halved each time on the left side. And that's what you write here. Or whatever you did. You could have tripled here. You could have reduced by a factor of 3. A lot of things you could have done. I think this is one of the simplest approaches though. Questions? For number 3, you're asked to find if these two ratios are equivalent or not. And one of the ways you do that is by simplifying them and then comparing their simplest forms. So I'm going to do that. And I already kind of started my work here, so apologies for that. But what can I simplify or reduce out of 14 and 16? What can I cancel out of 14 and 16? A 2, because 14 is 2 times 7, and 16 is 2 times 8. So that allows me to cancel out a 2 here, a 2 here, which of course leads me to the simplest form of 7 over 8. It's my first one. What can I cancel out of 42 and 64? Again, a 2. Because a 42 is 2 times 21. A 64 is 2 times 32. Now, as it happens, this is actually the simplest form because 21 is 3 times 7 and 32, there are no 3's or 7's in there. So, can't really do anything else. You might want to simplify it because it looks kind of big, but that's it. And I would compare. Is it the same fraction? No, it's not. Not equivalent. Questions on number 3? For number 4, you're asked to explain if the ratios are equivalent or not, or why the ratios are not equivalent. I've told you that they're not. You're supposed to tell me why and how can you find this. Does someone have an idea? Well, what I would do, I would first simplify both ratios. Number 2, I would compare the simplest forms to each other. And in this case, when I do that, I'll find out that the simplest forms are not the same. Thus, they're not equivalent. You could have written something else here, but this works. Questions? Alright, let's take a look at number 5 then, right here. And number 5 gives us this nifty little picture it took me a little while to draw. And it says, what are the 3 ways you can write this particular ratio? And I have the side of the house being 18 feet and the ladder being 14 feet. So what are the 3 ways I can write this ratio? Well, the first way is to put a 2 in between the 2 values, 18 to 14. The second way is to put a column between the 2 values, 18 to 14. And lastly, I can write it in fractional form with a numerator and denominator, 18 to 14. And that's it. Questions on number 5? Excellent. Last question on this page. 6 asks us, what is the difference between rates and ratios? Can someone tell me what is different between rates and ratios? Units. Units is what's different between rates and ratios. So you can say that rates have units. Ratios do not. And what I mean by that is that I can write 18 to 14 in the previous problem, and that would be a ratio. But for a rate, I'd have to write down 18 feet to 14 feet. I would have to actually include the 2 units in there. So rates are kind of like ratios, but with mandatory units in there. Question number 6. Number 7. Another versus question here. What is the difference between unit, rate, and just rate? Does someone have the answer for that? Alright, with rates, you can have 2 units and you don't necessarily lose any one of the ratios. You can have both ratios be present. In unit rates, the second part of the ratio, usually the second number, has to be 1, which it disappears. So for example, a rate can be 12 miles in 4 hours. That can be a rate. A unit rate, on the other hand, has to be a little bit different. Can someone tell me how this would look like as a unit rate? I would have to simplify this into 3 miles per 1 hour, which I can then write as 3 miles an hour. So in unit rates, what I'm trying to do is make the second half of the ratio or the rate disappear or turn into 1 by simplifying. Sometimes that means it's going to end up as a decimal. Well, that's okay. You have to go that far. If I ask you for a unit rate, I'm expecting the second part of the ratio to be gone, which means you have to simplify it in such a way that you only have the top or the numerator left. Sometimes it comes out evenly like here. Other times it would not. For example, if it was 12 miles every 5 hours, I'd have to use long division and find out what that would be. Questions on number 7? All right, number 8. All right, number 8, we have a bit of a word problem. It says Bob peels 22 potatoes in 4 minutes. How many can he peel in a minute? So they're asking us for a unit rate here. What can I do? Well, the first thing that I would do is I would set up my ratio. You always want to set up your ratio. What's my ratio here? Or the rate. 22 potatoes, which I want to simplify to just PT, over 4 minutes, which I want to simplify to just minutes. And yes, I'm including the units here because we are going to rates, and rates have to have the units in them. How can I simplify this down? What can I cancel out of both top and the bottom? A 2, because 22 is 2 times 11 potatoes, and 2 times 2 gives me 4 minutes, which means the 2 can be safely removed. But I'm not done yet. Because if I need the unit rate, this can't be a 2. What can I do next? I can divide 11 by 2, which gives me what? 5.5 potatoes per minute. And that's my answer. It's a unit rate, which means the second part is now 1, or it's technically gone, the second part of the ratio. Questions about number 8? Number 9 is another word problem. Here they told us, and I'll read it out loud, Jacob can detail 7 cars in just 49 minutes. Lisa can detail 6 cars in 39 minutes. Who's faster? Detailing usually involves waxing the car or whatnot. So how can I go about to find out who's faster here? I can compare the two rates here. I can compare Jacob's rate to Lisa's rate and then find out which one's faster. So I'm going to go ahead and write down the ratios or the rates for both. And I'm going to put the minutes on top. Why do I want to put the minutes on top instead of the cars on top? I want to put the minutes on top because if I don't, my answer is going to tell me how much of a car can Jacob wax in a minute. It'll work, but it's not very practical. Better to find out how long it takes him to wax one single car, as opposed to what part of the car he can do in a minute. That's why I want to put the cars on the bottom. The other way would work too, but you would end up with a decimal. So, hey, this is better. No decimals. And what does that give me? $7 minutes per car. And that's the unit rate for Jacob. Let's use blue for Jacob. Also the same thing for Lisa. Again, I'm going to put the minutes on top. And once you choose one method, you have to stay consistent. You can't put, minutes on top for Jacob, but then cars on top for Lisa. It's going to give you some weird numbers. So if you choose the other way, you stick to it for both. 39 minutes over 6 cars. All right. Now 39 and 6 doesn't go into 39 evenly. But what can I cancel out from both 39 and 6? If you said a 3, I totally agree with you. Because 39 is 3 times 13, and 6 is 3 times 2. This gives me 13 minutes over 2 cars. Still not a unit rate. What do I do next? I divide 13 by 2. And what's 13 divided by 2? 6.5 minutes per car. So if we're going purely based on speed, who in this case is the faster detailer, car detailer? Well, that's easy. Lisa's a little bit faster. She takes half a minute less to detail a car. So it's Lisa in this case. Questions on number 9? Alright, number 10 asks us if the two ratios I have here, are they proportional? Are they in proportion? How can I find out? Well, I can cross multiply them, and then if whatever's on each side is equivalent, then they're in proportion. So I'm going to do that. These two and these two are going to get multiplied. So let's go ahead and do that. So 6 times 4 has to equal out to 7 times 11. What's 6 times 4? It's 24, of course. And what's 7 times 11? 77. Is this in proportion? No, it's not even close. Nope, so a big X there. What about on the one on the right? Let's try that one out. Same rules. Top to bottom cross multiplication. We have 5 times 18. 6 times 15. A little bit tougher multiplication. Can someone tell me what those two are? 5 times 18 is 90. And 6 times 15 happens to be 90 as well. Didn't look like they were going to be the same, but they actually are. Kind of neat. They are indeed in proportion. Questions number 10. Alright, 2 more to go. Second to last problem here. Number 11. You're asked to solve this particular proportion. What would you do first? Well, just like in the previous problems, you would cross multiply. And you would get W times 5 equals to 16 times 10. Well, W times 5, that's easy. That's 5W. What's 16 times 10? 160. What do I do next? Divide both sides by 5. Anyone know what 160 divided by 5 is? 32. Now the second part says, how can you check your work? Does anyone know how I can check my work to make sure that it's correct? You can take this answer, plug it in right here for the W, and then do a cross multiplication and see if both sides come out to be the same, just like you did in the previous 2 problems. And I'm pretty sure they would. This makes sense to me. Questions on number 11? Number 12, I didn't write down because it was kind of long, but I'll read it out loud. A bag is a ratio of 6 red to 9 yellow candies. 4 yellow and 3 red candies are added to a bag. Did the red-yellow ratio change? Well, how would I start this problem? First, I would write down my original ratio of 6 red to 3 yellow. Alright, so we have 6 red to 9 yellow. It's my original ratio. Now what's my second ratio? What's my second ratio? Well, to obtain my second ratio, I'm going to add 3 to red and 4 to yellow. So what happens if I add 3 to red and 4 to yellow? 6 plus 3 is 9, and 4 plus 9 is 13. Are they the same ratio? Right away you can easily tell, because this one is in simplest form. This one's in simplest form, because you can't really do anything to the 9 and the 13. Sure, you can simplify the 6 and the 9 down into, you can divide them both by 3 into, let's see here, into 2 over 3. You could do that, of course. So that's the simplest form for this ratio. But still then, is 2 over 3 or 6 over 9 the same as 9 over 13? No, they're not. So you can say here that this one, the new one, the ratio changed. It's not the original 6 to 9 or 2 to 3 ratio of red to yellow. It's now something else. Close, but the ratio changed. It's no longer the same. Questions on number 12? Thank you.